Hi, I'm Taly Kanfi. I run the Solutions Architect team at Anomalo, and I am here to talk to you today about how Unity, Catalog, and Anomalo are, peanut butter and chocolate. They're made to be together. So who here has a job title where you work directly in data governance? Okay. Who here has a job title in data that's not directly working in data governance? Okay, just want everyone to get some exercise in the session. Don't be shy. So we like these cartoons because we think that, if you're working in data governance, you know what you're doing. But these kind of show what the rest of the organization, for people who don't work in data governance directly, might think it is. Everyone is always talking about it, but what actually does it mean to have excellent data governance in your organization? So everyone talks about it, but what is it? So we talk about 3 dimensions of data governance, right? And everyone talks about people and processes being a part of data governance, but I think it really boils down to these 3 points. Understanding your data. What is the universe of your data assets? What is its lineage? What PII do you have in your data? Access. Who can access which tables, right? How do you have the controls that you need to make sure that everyone can see as much data as will empower them to do their jobs well, but not see the data that should be sensitive and treated as restricted? And then finally, trust, right? What allows people to trust their data? And when I think about these 3 dimensions, some of them sort of lend themselves more to being reactive and being sort of restricting use of data in order to keep it safe, right? So we have to balance these risks, keeping the data safe, with enabling the organization to use data to make great decisions, because that's how data enables your business outcomes. So trust is a real key part of that proactive piece. And so Databricks understands this. That's why they built Unity Catalog. And it has unified governance for all data and assets. It has a single permission model, right? And it has open data sharing. And Databricks has built sort of some internal tools to let you do expectations, to use delta tables in order to work on trusting your data. But they really understand that this trust piece is most important. There was a really excellent blog written by the Databricks FSI team talking about the need for trusted data, and 89% of people surveyed said that data quality is their most impactful data priority. In order to succeed, we need to be able to trust the data. And so Databricks understands this, and that's why they've invested in Anomalo. That's why Anomalo won the Emerging Partner of the Year award from Databricks. It's because our products work so well together to kind of take trusting your data to the next level. So, why am I so passionate about Anomalo? A survey done earlier this year says that 77% of IT decision makers lack trust in their organization's data, and 91% think that their company's data quality needs improvement. And what that means is that the struggle today with data isn't how big or distributed your systems are, especially when you're using a super efficient data warehouse like Databricks, but it's, can you trust it? This is the core data issue that we're facing today. How did I get here? I have 18 years of experience as a practitioner in analytics, hands-on keyboard, doing the work. I started my career at Ernst & Young doing kind of strategic analytics. And then I worked at Redbox doing operational analytics. And most recently, prior to Anomalo, I ran an audience lab team at Epsilon. And what all of these jobs have in common is that I could tell you what I call a data quality war story about them. And that is when I'd been working on a project for 6 months or something, and then we discovered something about the data that we didn't think was there that fundamentally upended the project and means that we wasted, in the best case, days, but often weeks or months of work. And as my career progressed, I started to get wiser to the fact that this kept happening, and I started doing kind of skunkworks data quality, what we like to call the duct tape and chicken wire solution, this problem happened once, so I had a colleague set up a cron on their laptop to alert me if this column had suspicious nulls again. But it was always kind of this tension between doing the work that I was assigned, doing the projects that my team needed to deliver, and fixing these fundamental flaws in the data. When I first heard about Anomalo, I just had to be a part of it because I wanted to be a part of bringing the change where we can build data organizations where people are empowered to be proactive about these data quality issues and handle them in a consistent platform across the organization. So today we're going to talk a little bit about data observability and data quality monitoring. Who here has heard these terms? You came to the talk, so I'd expect some base knowledge on data quality. So data observability is kind of the simpler question of, is data moving through my warehouse in a timely manner, right? Are my jobs running, whether I'm using Airflow or Databricks workflows, are they running our time when each day is the latest data from yesterday available in my table? Data quality monitoring, and that's what we're going to focus on today, is a harder question. But is the data my warehouse produces high quality? And in order to do that, I need to actually query the data, not just the update times that I can see in Unity Catalog. So we want to talk a little bit about, we need to define success, right? So what makes for effective data quality monitoring? And I'm going to be coming back to these criteria a lot throughout the talk. So the first one is ease. How easy is it for someone to configure and execute the evaluation of data quality? The second one is it interpretable, right? There is a problem isn't useful information as opposed to, there's a problem in the Southwest region with the point of sale system. That's actionable information. Scalable, right? We need an algorithm that works for billions of rows, for tables with thousands of columns that's industry agnostic. Sensitivity. How small of a change can this algorithm find? And finally, comprehensiveness, right? Can the algorithm cover all of the columns, the metrics, the relationships, and the values in a table? So there's a few methods, and some of these are tried and true. I'm sure people in the room are familiar with them. The first is validation rules. Validation rules are like the database constraints of whether you implement them directly in the database, right, or you have some other system doing it. It's when you make sure a column isn't null, when you make sure that your primary key is valid. And what's really good about these is that they make sense to you, right? They're clear. What's hard about these is that they require a lot of user input to maintain. How many hours of your life in this room have you spent figuring out what the correct null threshold is for a database column, right? Some columns are easy, they shouldn't have any nulls. But other columns, 5% nulls is probably okay because there are nulls in the column. But if that 5% went to 10%, would you want to know about that? Should your threshold be 6% or should it be 10%? That's what makes validation rules not scalable. So then we have the next method, which is metric anomalies. So these are commonly used for the metrics that you're looking at in your business, for example, your sales or your website visits. And these also require user input to define. You as the analyst need to say, this is the metric that I care about. By using a time series model, then you can avoid that issue I was just talking about of discussing what the correct threshold is for an alert. You can rely on the confidence interval. But the problem with this is that most organizations have thousands of tables. A lot of these tables have dozens, if not hundreds of columns. So even at a 99% confidence interval, you're going to get a lot of false positives if you rely only on metric anomalies for your data quality strategy. So the question that kind of drove Anomalo's founding is, could there be a better way? Is there a third algorithm that offers an advantage over the two existing methods? So to summarize, let's talk about how these two methods scale up. Are they easy? That's the biggest problem with validation rules and metric anomalies, is that you as the data engineer, as the data analyst, as the data scientist have to specify your prior beliefs of the data in code in order for these metrics to do anything. Are they interpretable? The same thing that makes them cumbersome to implement actually makes them really easy to understand. Because you expressed your prior beliefs in the data, you can understand if those beliefs were violated, right? Are they scalable? They aren't scalable due to some of the challenges I just described earlier in the talk, that the people who best understand the data are often assigned to revenue-driving business projects, right? And don't have, their time is valuable to be fine-tuning these validation rules and key metrics. Are they sensitive? That's a key strength here, is that they can find a very small change in the data. A primary key constraint can find even a single duplicate value. And then finally, are they comprehensive? They're not comprehensive. Validation rules and key metrics are typically only monitoring like a single column in a table or maybe a column in conjunction with some others, but you can't create a single validation rule that's gonna say, hey, are there any anomalies across my entire table? So what is this elusive third method for scaling data quality? We call it unsupervised data monitoring, and I will go in a little further detail into the algorithm in a second. But the idea here is that the only input that the algorithm requires is a table. You can just point this algorithm at a table and it will let you know about unknown unknowns in your data. And that's what we're gonna focus on for the rest of the talk today. So I'm gonna walk you through a quick example of what this looks like in our product. This is some example data that we use for a lot of demos. It contains ticket sales, which means it's like, where was the venue? How much was the ticket? We're gonna focus in on this concert for The Who. You can see that the category, it's classified as pop. You may agree or disagree with that. That is not actually a data quality issue. It's an incorrect opinion expressed in the data. That happens. There's no algorithms that can detect those. And you can see here that, in fact, all of the concerts in this data set are classified as pop. This is what Anomalo looks like, and you can see on my table of ticket sales that everything is green, meaning that there are no data quality issues in the table. Has anyone here heard of the Netflix Chaos Monkey? Yeah, so I see some hands. So it's this very cool concept where they randomly terminate virtual machine instances to make sure that their infrastructure is resilient. And so at Anomalo, we have the Chaos Llama, which randomly introduces data quality issues to make sure that our algorithms are robust enough and able to find them. And we, in fact, have a whole library of these data quality issues to check for a variety of things that would occur in the real world. Like if a value is dropped from a column, right? Or the mode changes, or if the rows are all shuffled together. So I'm gonna introduce chaos. By the way, this is like every data governance person's like worst nightmare. I've seen a lot of data issues in my life, and the source of one of them was never, someone had too high permissions and they went in and deleted things from the raw table, but that's what I'm gonna do. I'm just gonna go to this fact listing table. I'm gonna say price per ticket. You are the target of my chaos. I want there to be more $10 concert tickets in the world because why not? I'm going to New York this weekend and I want cheap concert tickets, so I'm gonna constrain my chaos to there. I'm only gonna impact 30% of the records because I don't want to get caught for my diabolical plan. And I've specified the date that I want the chaos to occur on. Then I go back into Anomalo now that I've updated rows on the back end using the root permissions, and I'm going to rerun the check. And you can see here our execution log is going, and the check fails. And the important point here, I think that the slideware doesn't do the demo justice. You should stop by our booth and have one of our talented SEs give you a personal demo, is that we didn't tell Anomalo anything about the change, right? We just went into the back end of the database and wreaked havoc on the data, and then it's able to detect that. But what's really cool is when you click into it, the diagnostics that it's able to do on this data quality issue. So we can say that it's a strong anomaly cluster, and it identifies that the value 10 has increased in the price per ticket column. So we have a learned threshold in Anomalo of how noisy a column in a table typically is, and this was a severe anomaly relative to that. We also show you a lot of these visualizations, so you can see that this is a high cardinality column, as you would expect with ticket prices, and that there's this big spike at the value 10 in the overall data set. We also show you a sample of good and bad rows. This is a part of the product that I am specifically passionate about, because if you've resolved data quality issues before, right, and you have to work cross-functionally to resolve them, the first question you get is, can you send me a sample of the rows where the issue is occurring? Here at Anomalo, we just have that right in the app, and you can see that the 10 is highlighted. We have a sample of the most anomalous rows, and we also have a sample of the least anomalous rows. And then finally, we have this root cause analysis, where we're taking that sample of the most anomalous rows and that sample of the least anomalous rows and let you know what column value pairs the most anomalous rows are over-indexing on. So here, we've correctly identified that venue city equals New York City and venue state equals New York are correlated with the anomaly, because remember, when I was going rogue and hacking in the database, I confined my chaos to New York. So it sounds too good to be true, doesn't it? Let's talk a little bit more about how this algorithm works. So the way we do this is we take a random sample of data from today and a random sample from yesterday, and we ask the question, is there any material change between the two dates? And the trick here, the insight that lets us turn this unsupervised problem into a supervised problem, is that we turn this into a machine learning question, and we say, can we predict which day each record came from? So you can see here on my data set where I've added the ones and zeros to turn this into a machine learning data set. Right here. And then the other thing I need to do is auto-encode the features into this model. And so the things I'm going to consider are day of month, day of year, day of week seasonality. I'm also going to consider holidays to make sure that I control for them in the data. And then we can build a supervised machine learning model using a gradient boosted decision tree. And what you can see here is that the model is learning, right? So say I hadn't gone in and done that chaos in the data set, what you would see here is kind of like a straight line across the top as opposed to the decreasing slope. The decreasing slope shows that the model is able to predict which day the data came from. And if the model can predict which day the data came from, that's because there's something fundamentally different about it. And that's how we know that there is an anomaly. So you can see here with the log loss chart that in this case, that the model is learning, and that's how we were able to find the anomaly. However, it wouldn't be useful if I just said like, hey, there's a problem with today's data, but I didn't provide any context on what that was. So this part of the algorithm on its own isn't sufficient to create our scalable data quality solution. I need to make it interpretable, right, if we're going back to my criteria from the beginning. So I have my gradient boosted decision tree, but I'm going to use the SHAP package and SHAP values in order to credit changes to table values. And by table values, I mean each like row, column, pair, the actual values in the data set. So what does that look like? Here we have that same ticket data that thinks all concerts are pop, but you can see the SHAP values as a heat map against this. And this lets us credit each column value pair into how much did they contribute to the model, to the difference between today's, yesterday, and today. And you can see that the price per ticket column is lighting up in this data set because that's where we introduced the chaos. And by aggregating these SHAP values, we're able to compare the most anomalous rows to the least anomalous rows. And that's how we're able to generate that incredibly cool root cause analysis that I showed you, where we can see that the model identifies not just that there was an increase in the value 10, right, which wasn't there the day before, but also that the rows were confined to the city of New York. So what are some challenges that come up with this model, right? There's a lot that goes into doing this at scale. So first of all, we have seasonality, right? So this change happens every Monday. And the way we've handled that is by incorporating different forms of seasonality into our features, but we look not just at today and yesterday, but also today versus a week ago and today versus 2 weeks ago in case there was an issue last week to make the model robust. Time correlated features, right? So I gave away my question I was supposed to ask. How do you predict, what column will perfectly predict which data is from today and which data is from yesterday? And the answer is obviously the date, right? So we need to remove not just the date, and there's typically a lot of date and time columns. There can be a lot of date and time columns in a table. So we need to remove all the features that are correlated with time. But the other thing to think about is that a lot of IDs are correlated with time. Like say you have like a customer ID or an event ID that's always auto-incrementing. That could perfectly predict the difference between the 2 days as well. So we need to remove those. Chaotic tables, right? Some tables are noisier and some are a lot more stable, right? We use the example internally a lot of like Bitcoin transactions are incredibly noisy versus your dim customers table at say a large enterprise that's probably changing a lot more slowly. So we need to learn the noise threshold in the table in order for our algorithms to scale. Clustering across columns, right? We want to make sure that we're not finding 5 issues that are all actually the same thing. The best example here that we like to talk about is geography, right? A lot of times you'll have like city, state, zip, they're all really correlated. That was just like in the example, is it the state of New York or the city of New York? They're really highly correlated. Performance, we needed this algorithm to scale to billions of rows and thousands of columns so that it works on industry agnostic data sets. And in order to do that, the way we've done that is by using a sample of today's data versus a sample of yesterday's data. It's a perfectly random sample, it's statistically significant, and that's how we can find anomalies even on very, very large tables. And then finally, accuracy, right? We want to make sure that we're finding real changes and not saying, you know, like the mean of this metric shifted a tiny bit from today or yesterday, because the whole driving reason why this algorithm was created was to save the time of your data professionals so that you all can focus on the issues that really matter. So how do these methods measure up? Going back to my scaling method, right? And now we can add in the unsupervised data monitoring. So is it easy? This is a huge advantage of this algorithm. All you need to do is point it at a table and it will let you know about unknown unknowns in your data. Is it interpretable? Because we're using the SHAP values to explain what's going on, we're not just saying like, hey, there was a change from today to yesterday. We can tell you a lot about what that change was. Is it scalable? It's a lot more scalable than validation rules and metric anomalies because the only user input is required is a table, and we're using the history of your data to define what's normal instead of having your analysts, your data engineers, your data scientists express what's normal for your data in code. Is it sensitive? This is the one kind of drawback of this method is that, you know, if you have a single value that's off, like a single bad zip code, this algorithm won't catch it. The good news is that validation rules, which are kind of the simplest form of data quality rules, can still catch those single row failures for the handful of columns that are really critical to your business. And then finally, is it comprehensive? I think this is the coolest thing about this model is that it takes the input truly at the table level, because most other things like validation rules and key metrics require me to kind of specify things one column at a time or a group of columns at a time. Okay, so how does this all work with Unity Catalog? It works really great with Unity Catalog, spoiler alert, but what works less great is transitioning in the middle of your talk. So this is Unity Catalog, which I'm sure everyone here knows and loves, and it makes it really easy to find things in your data. I can type here and find some transactions, and I can see all of the different transactions tables in the data. And this really resonates me from when I used to be a practitioner. I would be assigned a project, right? And I would know like what tables I needed to use, but depending on how diverse my work was, sometimes I'd be like, oh, is that the table with credit card ID with or without the underscores? I don't know. And that's where a data catalog could really help me to figure those things out. But something that I also found in my work is that there was this tension between doing the work that I was assigned as quickly as possible to meet my sprint deadlines and doing a little bit of exploratory data analysis first, which was going to keep things from sneaking up on me downstream, for lack of a better word. So with our integration with Unity Catalog, when I look up the name of my table, I can also see here these checks that come from Anomalo, right? And I can see that some of them have passed and some of them have failed. And what's really powerful about this is that my data is changing every day. And there's no way you can document yourself out of being on top of all of those changes. You need the data to tell you how it's changed. So I can click here on the link to the Anomalo table, and see right here, and these are all of the different areas of data quality. These are the automated checks. This is where you can specify your own metrics and validation rules. But one of my favorite features of the product is that we actually also have all of these visualizations, right? Because the data can tell you a lot about itself via these visualizations. Here I can see the row count in the table. This visualization, I think, just anytime I would be doing an analytical assignment would save me about 2 hours of work, because the first thing you want to do is have some sense of the distributions of the key columns that you're going to be using in your analysis. We visualize those for you every day. So here you can see some credit limits that are really popular in this data set. We visualize the low cardinality columns, right? And we also have this numeric profile, because some columns are numeric. I might want to know what's the minimum, what's the maximum of this column on a different day, and just having this data snapshotted every day is going to save me so much time as a data professional, because I'm not going to have to do some bespoke analysis to do this, right? I can just come in here and look. And if there was a failure on this table that was material, right, I can see in Unity Catalog that like, hey, maybe I should take a look at this, look into what that is, right, before I do this project that's potentially based on numbers, right? There might be a bug going on. So it's really useful. Finally, we have a sample of the rows in the table. This saves a lot of time. I don't know about you, I have never outgrown the habit of, select top 100 from table, limit 100. If you're using a modern, you see how old I am since I said top. In order to just get a sense of what the data is before I start looking at it. So we have that in the tool. And then finally, this column correlation visualization, which it's using 5K, which is a correlation metric that works for both categorical data and numeric data. And it lets you know which columns are correlated. It's kind of a lot to take in, but I find it most useful when you have those analytical views that are composed of, say, your dim tables and your fact tables joined together. All of these little individual squares of correlation, that's how you can see the dim tables kind of coming together to join the table that's maybe going into your AI models or machine learning models. So with that, one more awkward transition back into PowerPoint. So this was my backup of the GIF doing the mouse. So we started, or not quite started, but earlier in this presentation, I talked about how 77% of IT decision makers said that they lack trust in their organization's business data. And what I want to think about, what could the reality be tomorrow when we have this really amazing culture of data governance powered by Unity Catalog and Anomalo? And it's less than 1% of IT decision makers lack trust in their organization's data. Because think about how supercharged your data teams would be in that world. All right, thank you all for your time.
Thanks, Taly. Thank you very much.